Hello everyone, welcome to YouTube channel Genetics. Now in this particular video, we are discuss about retrievers for our RAG architecture. This is the one of the another most important component for RAG. So try to understand it clearly. So let's get started. So what is the definition of retriever? A retriever is an interface that accepts a natural language query and returns a list of documents. That is text and metadata. Text means page content that we have already seen in our previous examples. Okay. It's more general than a vector store. Retrievers can be backed by vector indexes, keyword engines, web APIs, SQL, etc. Now see what happens. I show you. Suppose this is our vector store. Okay. Vector store. Now user asks and query. Okay. Now we use the query. Now this query gets embedded first. Right. We have already seen this. And this embedded vector goes to vector store. Right. Then vector store perform the similarity search operation over here and get the all relevant documents. Right. We have already shown these examples. So whenever user asks any query, that query goes to a vector store, and vector store try to find out the relevant document by performing the similarity search operation and retrieve the relevant documents. Right. In the same way, retriever works in the same way. Now retriever also retrieve all the relevant documents. Okay. Now what's the difference between retriever and vector store? See, using retriever, we can also fetching the same all relevant documents, but using retriever, what happens? Using retriever, we can get more relevant document than vector store. Okay. And also we can perform different type of strategy. Now in case of vector store, we can only performing only similarity search operation here, but using retriever we can perform similarity. One is similarity search. Okay, similarity search, the one of the strategy. Second, we can use MMR. This is the another strategy. I tell you what is this. Third is scoring factor. Using scoring, we can use any kind of retriever and get the relevant document. Now see, these all type of techniques we can use using retriever that we cannot use in vector store. Okay, that is why it is written here. Retrievers, it's more general than a vector store. Okay, and another is retriever can also backed by vector index. Another is using retriever we can suppose this is our vector store. Okay, this is our own data, right? So we are using in RAG. Suppose we want to access the data from outside our vector store. Suppose from Wikipedia. You might be knowing Wikipedia. Suppose we want to get data from Wikipedia. Then what we have to do? We have to use an external API. Right? External API. And there is an API is Wikipedia retriever. This is the one type of retriever. So this type of, if we want to use this type of external data source, then we have to use this type of API retriever, right? So we using vector store, we cannot access any data source outside of our database, right? So that is why we have to use retriever in that case. So there are multiple advantage of using retriever rather than vector store. Okay, so that is why it is written over here. It's more general than a vector store, right? So next is types. What types of retriever are there? See, first one is vector-based retriever. Okay, this is the simple that I have already shown you, that is vector store and performing similarity search. Okay, this is called vector retriever. Okay, second one is sparse retriever. that is BM25. Here, instead of performing similarity search, we perform keyword matching operation over here. And here, we do not perform embedding. Okay. So in case of sparse matrix, whatever data we have, we do not perform it embedding, and instead of similarity search, we perform keyword matching. Okay. I'll show you everything one by one with examples. Don't worry. The third one is ensemble or hybrid retrieval. Here we perform these both. We can perform vector or dense retriever along with sparse retriever. Okay, so both retriever perform parallelly in case of ensemble or hybrid retrieval. Okay, fourth one is contextual compression retriever. Here what happened, once we got our relevant document, then retriever try to compress it and finally give the final output. Okay, this is the another way. And the last one is multi-query retriever. Here what happens, here retriever using LLM retriever create multiple query against a single query, and then they find all the relevant documents for all the query. Okay, for all the query. Once they get all the relevant document from every query, then they finally combine all the output and then give the final output based on our requirement. Okay, this is the multi-query. So this is how these retrievers work. So let's see one by one with example. So first one is dense retriever or vector store retriever. Okay. So a retriever that uses embedding plus vector similarity to find relevant documents. Okay. Documents are embedded and storing vector store. Query is embedded and nearest neighbor are returned. So we have already shown you. First our document gets embedded and then storing vector database. Right? And once we got the query, then we try to find the relevant document. Okay. So this is a vector store. How it works? Create document object. First, that already we have shown you. Use an embedding module to embed each document. Now, first this is our document. Then it's get embedded here. Store embedding in vector store. Now it is stored in vector store. Okay, and this type of store we have already seen the example, fires, comma. Fourth is at query time, embed the query. Then query gets embedded. Right. Now finally compute similarity cosine dot L2. Finally compute a similarity search using cosine dot or L2. These are the techniques to perform the similarity operation between query embedding and store embedding. Between this document embedding and the query embedding. Between these two embedding perform similarity search and finally return top K document. Okay. This is our dense retriever or vector store retriever. So let's see how it is happening in practical. Okay. Okay guys, so I have opened our VS Code. Now this is our 10th session. So I have already created the file for retriever.ipynb. Now see, this is the first example is vector store retriever. Now this is our example. Now for starting our coding, we have to import our document. For document, for creating our document object, right? Then for embedding model, I am going to use Google Generative AI embedding model. Okay, and as a vector store, I am using files. Okay. Now I'm creating this document, this docs, using this document object and creating 5 document. Okay. Now initializing my embedding model, Google embedding model is Gemini embedding 001. Okay. Now I'm creating my vector store. This all example I have shown you in earlier. So using this files.from document, I am creating my vector store. Now see, once my vector store got created, then there is a function as retriever. Okay, using as retriever, VS means our vector store dot as retriever. Using this function, we are using our retriever and performing our similarity search operation here, and mentioning search squared equal to k equal to 3. That means we want top 3 document. Okay, so this is the by default search similarity search operation is performing in over here. So we are putting in retriever, retriever equal to vector store dot as retriever and putting k equal to 3. Now we are passing these are query is which animals are domestic pets. These are our documents. Python is a programming language, Java is also a programming language. Cats sleep during often during the day, dogs bark at stranger, birds fly in the sky. Now we have this is our query. Now we are invoking our query using the retriever that we have created. Okay, and printing our documents, metadata and page content. Now let's run it. Now see. Birds flying in the sky, cats sleep often during the class, and dogs are bark at stranger. Because as we have asked which animals are domestic pets, so among this document, cats, dogs, birds, these all are pets. So that is why our retriever fetch these 3 documents: ID number 5, ID 3, ID 4. Right? Because our retriever performing similarity search, and he got the similar context from ID number 5, and this document, from this document, and from this document. Okay, and these 2 documents are more irrelevant. That is why it is not present here. Okay, so this is how retriever works. Now see, in our previous class I have already shown you this similarity search operation also performed by vector store, right? So see, this is the example. In the same way, this is our vector store. Okay, now this is our query, and we are performing similarity search. You have remembered in last class I have shown this example: vector store dot similarity search, and we are passing our query, and we want top 3 document. Okay, now printing our documents. Now see, if I run this one, now see, here also we got the same, almost same result, but the thing is here the document 1 is printing. Python is a programming language. Now see, this is the difference between vector store and retriever. Using vector store, we can getting our result, but what happens is when we are using retriever, then our answer is more accurate, right? More accurate. Birds, cats, dogs, like this. But in case of vector store, we are getting Python, Java, all these things. Okay, so it is quite irrelevant when we are using vector store. But if we are using retriever, then it is more related to our query. Okay, that is why we are using retriever. That is why we instead of using vector store, we use retriever. Okay, and the third one is, I told you using retriever we can use different type of strategy. So this first one is by default similarity strategy. Okay, but here another example I have shown you. Till here everything is same. Now we are initializing our retriever base.addRetriever, and here we are mentioning search type as MMR. MMR is maximal marginal relevance. Okay, this is a strategy where basically it balances between relevance and diversity. So means relevance is how our retrieved document is relevant to our query. Okay, these are relevance, and diversity is how much our retrieved documents is different from the already retrieved documents. Okay, this is the diversity. So basically MMR balancing over here. So basically what happens when we retrieve our documents like this, sometimes what happens, sometimes we all the output, all the documents are quite similar. Okay, so getting multiple times the similar type of answer, what happens using MMR, we can reduce the noise, you can reduce the same repetition of the answer, and we can add variety of documents. Okay, so this is how we can get more relevant document of our query. That is why we need to use MMR. Now see, these all are same. Now we are putting search type as MMR and rest are same. Okay, now let's run this code. Now Python is programming language, Java is also programming language, Cat all are same. The previous one. Now see what is happening. Now which animals are domestic pets? Now this also gives birds flying, dogs barks at stranger, cats are sleeper. Okay, and one more thing, when we are using MMR, we have to pass search query k equal to 3 means we want our top 3 document. Okay, fetch k equal to 5. That means we want retriever to retrieve top 5 document before applying MMR. Okay, so before applying MMR, we want top 5 document, and among them we are using lambda mult equal to 0.5. This is actually balance factor. Okay, lambda mult actually is a balance factor. When we mention here 1, that is we want more relevant documents. When we pass as 0, then we want pure diversity, and when we are passing 0.5, that means we want balance. Okay, so here we mention 0.5 as a balanced result, and we want 5 document, and once they apply the MMR strategy, then finally we want our top 3 document. That is there mentioned here. Okay, so this is how initially in the backend MMR strategy find first 5 documents. Among them they find finally they print the top 3 document. Okay, this is how MMR works to get the more relevant document. As our document is very less, that is why you are getting the same result here and similarity search over here. But if our document is big, then you can find the different. Okay, this is here we can get only similarity search. Okay, similar document, and here also we getting the similar documents, but in more accurate way. Okay, in more accurate way, using by adding different type of variety. Okay, so this is how MMR works. Now next is sparse retriever, that is BM2 retriever. So is sparse retriever in LangChain matches document by keywords. Do not use embedding good when exact keyword matters. So I have already told you in sparse retriever we do not use embedding, and we perform keyword matches. Okay, now what happens, suppose these are our documents. Okay, once user gives the query, then based on the query, what happens, BM25 retriever assign a BM25 value to each document. Okay, BM25 value, BM25 value. Okay, so based on the query, BM25 value has been assigned to each document, and this CLSD in descending order, and after that they give the top K 11 document. Okay, and they perform the exact keyword match. If we ask for dog, then they will try to find out the document which is the exactly matching with dog. Okay, this is how the BM25 retriever works. Okay, how it works now, build an index of documents. Okay, tokenize them, compute term frequency, inverse term, that is TF-IDF. Okay, when a query arises, pass the query terms, compute BM25 score that I have already told you to each document based on the overlap and term statistics, that is backend operation. Okay, return top K high scoring documents. Okay, this is how basically BM25 retrievers works. Okay, so let's see in practical. Okay guys, so this is our BM25 retriever example. So we have to import this BM25 retriever from LangChain community retrievers. Okay, and in order to run this retriever, you have to install one library, that is lang_BM25. Okay, so I have already installed this library. Now the second one is document. Now I'm importing document in order to create our document object. Okay, now I have created this 5 document, list of document. Okay, now I'm getting this retriever BM25 equal BM25 retriever dot from document, and I'm passing my documents, and I want top 3 result. That is why key equal to 3. Now I'm running my query, result equal BM25 dot info, and passing my query, that is sky blue animals, and now printing my result as metadata and page content, both I'm printing. Now let's run this cell. Now see, we get the result. Now as I have already told you, BM25 retriever works not in similarity search wise. Okay, it is searching basically, it is performed in the basis of keyword matches. Okay, So as I'm pass sky blue animal, so see in first ID sky and blue is there. In second, sky is there. In third, blue and animals is there. In fourth, sky is there. And in fifth, there is no such element. And among these four, 1, 3, 4, these three element has been picked up. Now you might be thinking there's in the same ID there is there's this also sky is there, but it is not get picked up. Now see, I already told you, when we are passing any query using this BM25 retriever, then this retriever creates BM25 value to each documents. Okay, then they serialized it in descending order. And based on that, as I have mentioned 3 document, that is why they give the top 3 result. Okay, and how they assign this BM25 value to each document? So there are multiple ways. One is the length of the sentence. Second is how many times does the same keyword, the query keyword is coming in that particular sentence. Okay. And the third is which the sentence is how much relevant based on the query element. Okay. And all based on all these techniques, they assign the BM25 value. Now, if you see in this section, in this document, we have two elements that got matched: blue, sky, and blue. Okay. Here only sky is there. Here blue and animal is there. Here sky is there, and here no matching, right? No matching. Now see, as in this first document, 2 element got matched, that is why it got prioritized first. Okay. Then in third ID, there is 2 element got matched, that is why it got prioritized in second. And this got neglected because there is no matching. And between this ID number 2 and 4, in both sentence only single element got matched. But why did this sentence got picked up? Because as per retriever, this sentence get more relevancy based on the query. Okay, that is why this sentence has been picked up. Okay, so this is how BM25 retrieves our relevant document based on our query. Okay, I hope guys you understand. The next one is ensemble or hybrid retriever. Okay, use multiple retrievers in parallel, sparse or plus days. Combine result to the improve recall or precision. Okay, how it works? Run each retriever separately. There, suppose first is vector store and second is BM25. Okay, suppose. Okay, let me change my color. Suppose first is sparse mean vectors retriever, vector store retriever, and second dense is BM25. Okay, so when user asks any query, then retriever performs these 2 operations parallelly. Okay, parallelly. Run each retriever separately, but it is performing parallelly. Okay, each gives ranked list of document. Both of retriever gives separate document based on the rank. Okay, combine result using weight or method. There are multiple different type of method is there. Using that, they assign the weight and they combine all the result. Okay, combine all the result, and finally gives the final output. Okay, so basically this is how hybrid retrieval works. Hybrid is calling because it is using both sparse and dense retriever all together in parallelly, and they combine all the result from both retriever and finally give the output. That is why it is called ensemble or hybrid retriever. Okay, now let's see the practical. Okay guys, so this is our third retriever, that is ensemble or hybrid retriever. Okay, so as I told you, in hybrid retriever, we have used BM25 and vector retriever both all together. Okay, so that is why first we are importing document in order to create our document object, then BM25 retriever, then to create our embedding documents, we are using Google generative AI embedding models, and as a vector database using Sparse, and we are importing Ensemble retriever, okay, from LangChain.retriever library. Okay, now I'm creating this document. The first document is AI research is going first. Machine learning models perform many tasks. Cooking are and baking are arts. Dogs are loyal animal. Software engineering with a discipline. Okay. Now first I'm creating my BM25 retriever. Okay, BM25 the BM25 retriever dot from document, and I'm passing my document, and I'm putting k equal to 2. Okay. Now this is my BM25 retriever. Now I'm creating my vector retriever. Okay. Embedding model. I'm passing my embedding model. Then I'm creating my vector store files dot from document and passing my document. Embedding equal to emb, this variable, and then creating my retriever as bs.as retriever as such quack equal to k equal to 2 top to result. Okay. Now my PM25 retriever and GET retriever both are ready. Now I am calling my Ensemble retriever, and within this retriever I'm passing my both retriever. Okay, as retriever equal to BM25 and vector retriever, and putting weight 0.5 for both. Okay. So using this Ensemble retriever, I'm passing both retriever, and I am giving the instruction to run these both retriever parallelly. Okay. Now this is my query. What are the models in AI? And creating result Ensemble. This one Ensemble.ebook, and passing my query and printing my result, metadata and page content. And let's run this cell. Now see, ID number 1 and 2 got fetched. AI research is going first. Machine learning is model performs many tasks. Okay. Now this two document has been fetched. Now basically what happens when I'm passing my BM25 retriever and k equal to 2, then my BM25 it keeps 2 element, top 2 element based on the keyword match. Okay. And when I'm passing vector retriever, then they also fetching the top 2 element based on the similarity search. Okay. Now finally using this Ensemble retriever, we are combining both result that is coming from BM25 and vector retriever. Okay. I'm combining both document, and among that 4 document, these two and these two, among these 4 documents, we are finally fetching the top 2 result. Okay. Using this retriever, what is the advantage of using this retriever? That is, first of all, we are getting a similar document using this vector retriever, and at the same time we are getting the same keyword documents using BM25 retriever. So that is why we are getting that whatever result we are getting, that becomes more relevant and more accurate based on our query. Okay, that is why we use Ensemble or hybrid retriever to get more accurate result. Okay, so I hope you understand, guys. If you have any doubt, just go back to the video and try to understand it one again. Okay. Now next is Contextual Compression retriever. A wrapper retriever is basically wrapper retriever. First retrieves documents via base retriever, then compress or filter the content according to the query. Okay, only parts of the document relevant to the query server. Suppose first we have to use our normal retriever. Okay, base retriever. Suppose we retrieve our top k equal to 3, top k 3 document. Okay. Now once we got the top 3 document, then what happens? Within compressor we have to mention one threshold value, similarity threshold value. Okay, similarity threshold. Okay, threshold value. We have to mention similarity threshold value within the compressor. Now we got our 3 document. Now suppose we have mentioned similarity threshold value is 0.5. Now among these document, those document matches our threshold value, only those document will finally comes in our output. If suppose in among 3 documents, if this document and this document got the threshold value of 0.5, then we get the only these 2 document. This document will be removed. Okay, this operation performing because using this operation we reduce the noise first of all. Secondly, we can limit our token, and third one is we can get more relevant document. Okay, this is why we use compression retriever. So I hope you understand. In using the threshold value, we are omitting our irrelevant document from our final top document, okay, and getting the final output which is more relevant using compressor retriever. So let me use it. So how it works? Now use a base retriever. I told you use a base retriever, vector or sparse, whatever it is. We get our candidate document, our documents, all that relevant documents. Now use a document compressor to process each retrieved document. Okay, extract, filter, or summarize the part of the most relevant query. I told you using the compressor, basically using the similarity threshold value that we have to mention in our compressor, we can filter or extract our relevant document. Okay. Now finally return the compressed document. Whatever you get, we are finally getting our final document that is get extracted. Okay. These are on our compressor retriever works. So let's see the practical. So guys, this is our contextual compressor retriever. So first of all, I'm importing document, then my embedding model, then my vector store, then contextual compressor retriever, and we have to import it from LangChain dot retriever. And in order to filter out my compressed document, we have to use embedding filter, and we have to import it from LangChain dot retriever dot document compressor. Okay. Now I'm creating my document. This 5 document object I have created. The first one is Python is a programming language used for web development and data science. JavaScript runs in the browser, useful for interactive web pages. C++ is compiled and used for system programming and games. Rust M for safety and performance used in system software. Cooking recipe often requires precise measurement and timing. Okay. Now I'm creating my base retriever. Here I'm using vector retriever. You can use BM25 retriever as well. So whatever you want, you can use as a base retriever. So here I'm using, first of all, I'm using my embedding model. Then I'm creating my vector store, and I'm getting my retriever. So my base retriever is ready. Now I'm creating the compressor. Using embedding filter, I'm passing my embedding model and similarity threshold value, that is 0.5. That is my requirement. Similarity threshold value. Okay. Now creating my contextual compressor retriever. Now contextual compressor retriever, within this you have to pass 2 parameters mandatorily. One is base retriever and is base compressor. So within in base retriever, I'm passing my base retriever, and in base compressor, I'm passing my compressor. Okay, I'm passing my compressor. Now my retriever is also ready. Now this is my query. Which language are good for system programming? Now creating using my retriever, I'm invoking my query and printing my documents. Okay, metadata and page 1. Now let's run this cell. Now see. Rust aims for safety and performance using system software. C++ is a compiled used for system programming, and Python is the programming language. This ID 431. This 3 document got fetched by our retriever. So basically, what is happening? First of all, my vector store fetching the top 3 result. Okay, then it is passing to the embedding filter, and here I mentioned similarity threshold equal to 0.5. So among these 3 documents, those documents are got matched with this threshold value. Only that documents will be finally fetched out as an output. Okay, so these are basically operations performing over here. Now among these 3 results, all have the same similarity threshold value. That is why it is showing the top 3 result. As our document is very small, that is why our 3 element is showing. But if our document is big, sometimes you might be seeing that your whatever you have passed in K value, you might be getting lesser output, because if my similarity threshold value doesn't match, then it will not come as output. Okay, so in this example, this short document, that is why all the 3 documents got have the same 0.5 similarity threshold value. That is why it's coming here. So basically, in the backend, this operation has been performed. First of all, our base retriever retrieves the documents, then it is passing to the embedding filter, and among that documents, whatever passed to the embedding filters, those documents got the same similarity threshold value. Only those documents will be coming out as a final result. Okay, this is how basically our contextual compressor retrieves. So by doing this, we basically compress our final output. We limit our token. We remove our noise. Okay, so that is why we have to use contextual compressor retriever. Okay, so I hope you understand, guys. Okay guys, so our next retriever is multi-query retriever. Okay, so what is that? A retriever that uses an LLM to generate multiple reformulation perspectives of the user's query, then retrieve for each of them and returns the unique opinion of the ball result. Okay, helps cover cases where the query, phrasing, synonyms, or perspective might miss relevant document. See what happens basically. It my query is suppose I'm passing my query as what is AI. Okay. Now once I pass the query, then what does this retriever do? Now this retriever uses our LLM model. Okay, and using this LLM model, it generates some few other alternative query against this main query. Okay, suppose what does AI mean? Okay. Another might be how does AI works? Okay, like this. So using LLM, this retriever creates multiple query against our main query. Okay. Now if we mention k equal to 2, then for each query we'll retrieve 2 relevant document. Okay. Each query will retrieve 2 relevant document. And once they retrieve that 2 documents in each query, then they will combine this 6 document. Okay. Now they combine the 6 document, then they remove all the duplicate value. As these questions all almost same in same category, that is why it might be retrieved the same document, right? That is why when we got the 6 document, then it will duplicate all the it will remove all the duplicate value and finally gives the output, and it gives the remaining output. It might be 2 or less. 2 or less. Okay, as we have mentioned k equal to 2, so it might be 2 if after reviewing the duplicate value, if my document remains 2, then it will give the 2 result. If it removes most of the duplicate value, then it will give the less value. Okay, so this is how my retriever multi-query retriever works. So let me erase it. Now it is written here how it works. Receive user query, generate multiple query via LLM, and for example, what are the reason for X, how is X done, and etc. Okay, that I have already shown you. Use a base retriever, vector or BM2, whatever retriever you want, you can use to retrieve document for each generated query. Okay, each generated query. Combine result. They are combining all the result, that is basically union and optionally deduplicated. Okay, basically if there is duplicate value, then they remove the duplicate. That is why this is showing optionally if there is duplicate value. And finally, they return the combined set of documents. Once they remove all the duplicate, then they finally gives the final output. Okay, this is how multi-query retriever works. So let's see in the practical. Okay guys, so these are multi-query retriever. Okay, so first of all, we are importing our document, then embedding model, then vector store files. And in order to use our multi-query retriever, we have to import multi-query retriever from LangChain.retriever.multi-query. Okay, and I'm importing my LLM model, chat, OpenAI, and loading my environment. Okay, now I'm loading my environment. Now creating my document. These are 5 documents. Machine learning includes supervised, unsupervised, and reinforcement learning. Deep learning used naturally works with many layers. Statistics is fundamental to ML. Reinforcement learning deals with agent, viewers, and environments. Optimization methods like gradient descent are used in training model. Okay, now I'm creating my base retriever. Okay, using vector store. Now this is my embedding model. I'm creating my vector store. Now this is my retriever. Okay, now my retriever is ready. Now I'm initializing my LLM model, chat OpenAI model. I'm passing my model and template 0.7. Okay, now creating my retriever. My retriever dot from LLM. We have to use this function dot from LLM. So dot from using this function, this retriever will create a few more query based on our main query. Okay, so multi-query dot from LLM, we are passing our retriever LLM and including original equal to. Including original equal to means we want to keep our original query. Okay, that is why we have to mention include original equal to. Now we have this is our query. What is reinforcement learning? And we are invoking our query using multi underscore this one. Okay. Now printing my result. Now let's run this cell. Now see, we got these two results. Reinforcement learning deals with agent, viewers, and environment. Machine learning includes supervised, unsupervised, and reinforcement learning. So basically, what happens? We are passing this query. Okay. Once we pass this query, then this retriever creates another two query, because if we don't mention anything over here, it is by default creating 3 queries. Okay. So once we pass this query, then this retriever creates another 3 query based on our main query using our LLM modeling. Okay. Then once they create all the query, then each query retrieve top 2 documents. Okay, they retrieve top 2 documents, and finally they combine all the documents and remove all the duplicates. Then finally gives the top 2 result. Okay, these are our multi-query retriever works. They create multiple query, they retrieve multiple documents, they remove the duplicates, and finally gives the output. Okay, that is why we have to use multi-query retriever in order to get more relevant document based on our query. Okay, so I hope you understand. So guys, by doing this, we have completed our retriever. So there are many more retrievers in LangChain. So if you have interest, then you can refer LangChain documentation. Okay, but retriever is very important component, guys. So you just try to revise it again and again. Okay, so let me push it in GitHub. Git push or reduce. So guys, I'm pushing all the codes in my GitHub. I'll give this link to the description box, so you can check it over there. And so finally, we're finishing our video. And guys, if you are still liking my videos, please do like, share, and subscribe my channel. Thank you so much.